Welcome to my class, Motion Part 3. In our aerial classes, we discussed what is speed and what is displacement. In this session, we are going to discuss how to represent motion on the graph paper, that is graphical representation of the motion. Children, let us discuss two types of graphs, that is the first one is we are going to discuss distance and time graph and velocity and time graph. What is the first one? Distance and time graph. What is that? Distance and time graph and velocity and time graph. In the name itself, distance and time graph. What is meant by distance and time graph? A graph drawn by taking time on x-axis and distance on y-axis. What is that? It is a graph drawn by taking time on x-axis and distance on y-axis. Okay, the second one is the velocity and time graph. This velocity and time graph is drawn by taking time on x-axis and velocity on y-axis. Are you clear about that one? So we can represent motion. We can represent motion using the graphs. There are two types of graphs we are going to discuss in this session. One is the distance time graph and the second one is the velocity and time graphs. Before going to discuss these, before going to draw distance and time graphs and velocity and time graphs, it is better to discuss what are the symbols we use in this lesson. Distance is always denoted with S and displacement is always denoted with delta S. Initial or initial speed, initial velocity or initial speed always denoted with U, and final velocity is always denoted with V, and time always represented with small t, and acceleration is always represented using the small a. Okay, and we have to remember one more thing, velocity is velocity or speed always represented using the symbol V. So we have to remember these symbols. As per NCERT norms, we have to use these symbols in this lesson motion. Okay, let us discuss what is distance and time graph. We will discuss what is distance and time graph in detail. Okay, what is the graph of distance and time? We will discuss. See, what is distance and time graph? It is a graph drawn taking time on x-axis and the distance on y-axis. Okay, observe this one. This is the x-axis. Observe this one. This is the x-axis. On x-axis, we are taking time in seconds, and this is a distance. Distance is taken on the y-axis. Okay, distance is measured in meters. Are you clear about that one? So time is measured in seconds, whereas distance is measured in meters. Okay, distance is always taken on y-axis and time is always taken on x-axis. So if you plot the graph by taking time and distance, okay, time on x-axis and distance on y-axis, you will get a line. You will get a line. Observe this one. So this line is straight. Okay, you will get a straight line. Are you clear about that? With the increased value of time, observe this one. For 1 second, distance traveled by the body is 5 meters. For 2 seconds, the distance traveled by the body is 10. Okay, for 3 seconds, it is 15. For 4 seconds, it is 20. For 5 seconds, it is 25. If you observe this one, what is the speed here? Distance by time. What is distance here? 5 by 1, that is 5 meters. Here in the second instant, 10 by 2, that is again 5 meters. Okay, so here the speed is constant. The speed is constant. Are you clear about that one? So the graph of the body moving with a uniform speed or uniform velocity is a straight line. Okay, it always indicates, represents a straight line. That straight line always indicates what is that? Uniform speed or uniform velocity. The body is moving with a uniform velocity. Observe this one, uniform velocity or uniform speed. The magnitude of the speed is nothing but velocity here. So the graph represents, observe this one, this graph always represents the motion of the body moving with a uniform speed or uniform velocity. Are you clear about that one? So the thing you have to remember is, the graph of a body which is moving with a uniform speed or uniform velocity is a straight line. Is a straight line. Are you clear? Now see this one. The slope of this line always indicates, what is that? The slope of the line always indicates the speed or the velocity of the body. Speed or velocity of the body. Observe this one. See this one. If you are given 2 points A and B and you are asked to find what is the distance traveled by the body, what is the distance traveled by the body from A to B. So with the help of the graph, we can find the distance traveled by the body from A to B. For that one, what you have to do? First, draw the vertical to the x-axis from the point A and you draw another vertical from the point B. Okay, they cut the time axis, that is x-axis, at T1 and T2. Next one, in the same manner, draw the parallels to the x-axis from the point A and from the point B. So the parallel drawn to the x-axis cuts the y-axis at S1 and parallel drawn to the x-axis cuts the y-axis at S2. Are you clear about that one? So S1 and S2 indicates distances and T1 and T2 always indicates time periods. Are you clear about that one? Now observe this one. What is the distance traveled by the body from A to B? From A to B. See this one. This is the point A and this is the point B. So what is the distance traveled? That is S2 minus S1. That is S2 minus S1. In the same manner, what is the time taken by the body to travel from A to B? That is T2 minus T1. Observe this one. T2 minus T1. We know that speed or velocity is nothing but distance by time. Distance by time. That is d by t. So what is the distance traveled by the body? That is speed or velocity is equal to S2 minus S1 by T2 minus T1. With this formula, we can solve the problems based on graph. Based on graph. This is a new formula which is used to find the speed or velocity. Okay, are you clear? Let us study the motion of the body moving with non-uniform speed. Non-uniform speed. For a body which is moving with non-uniform speed or non-uniform motion, the graph of distance and time. Okay, graph drawn to distance and time is a curve. Is a curve. It is not the straight line. Observe this one. The curve may be like this or the curve may be like this. In any manner, it is a curve. So the simple thing you have to remember, for a non-uniform motion, that is when a body is traveling with non-uniform speed or velocity, the graph is a curve. The time distance graph is a curve. Let us discuss what is meant by acceleration. The rate of change of velocity of an object, the rate of change of velocity, wherever you find rate means it is related with the time. So the rate of change of velocity of an object is called acceleration. So as you know that acceleration is a vector quantity. It is a vector quantity. It has both magnitude and direction. It is denoted by the letter small a and the units are meters per second square. The units are meter per second square. Acceleration may be positive or negative. May be positive or negative. Next, the negative acceleration is called retardation. It is called retardation. When the acceleration is positive, if the speed of the body increases, if there is a change in the speed of the body, velocity of the body changes, okay, increases, then we say that the body is moving with the positive acceleration. Okay, next one, if the speed or the velocity of the body goes on decreasing, then we say that the body has negative acceleration. The negative acceleration is also known as retardation. It is also known as retardation. For example, you take the case of a train leaving the station, platform. So in the beginning, its speed, it starts with the certain speed, and then its speed goes on increasing, then we say that it is moving with positive acceleration. Okay, next one more thing we have to remember, when do we say the body has positive acceleration, moving with the positive acceleration means, the simple thing, if the final velocity is more than the initial velocity, then it has positive acceleration. If the final velocity is less than the initial velocity, that is v is less than u, then we say that the body is moving with negative acceleration. Are you clear? Next, the acceleration may be zero. When do the acceleration is zero? If the initial and final velocity is same. Okay, if the initial velocity and final velocity is same, then the acceleration is 0. Let us discuss the second type of graphs in motion, that is velocity and time graph. What is velocity and time graph? It is a graph drawn by taking time on x-axis and the velocity on y-axis. For uniform motion, the graph is a straight line parallel to the x-axis. Observe this one. This is the graph drawn by taking time on x-axis. Time is measured in seconds and velocity is measured in meters per second, and the velocity is taken on y-axis. Okay, now you got a graph. See, this line is parallel to x-axis. This indicates, what is that? The slope of this graph indicates the acceleration. It indicates the acceleration. Observe this one. See, this is the time. As the time goes on increasing, but the velocity remains constant. So this is the graph of uniform motion. Okay, by taking time on x-axis and velocity on y-axis. Now you observe the second type of graph, that is uniform accelerated motion. In the case of uniform accelerated motion, with time, as the time increases, see this one, as the time is increasing, the velocity goes on increasing. See this one, see, observe this one, the velocity goes on increasing. Okay, so this is the graph of uniform accelerated motion. Are you clear about that one? So this is uniform motion where the velocity is constant. Observe this one, the velocity is constant, whereas here, observe this one, the velocity goes on increasing with respect to time. So this is the graph of uniform accelerated motion. See this one. What is the advantage of this graph? While solving the problems related to distance or displacement, see, if you are asked to find what is the distance or displacement of the body from A to B, observe this one. See, for that one, what you have to do? You have to draw the perpendiculars to the x-axis. Let us assume a perpendicular drawn to the x-axis, cut the x-axis at the point D, and another perpendicular drawn from the point B, cuts the x-axis at C. Are you clear? Next, now you got a quadrilateral. It is a quadrilateral. Observe this one. This is a quadrilateral. The area of this quadrilateral, gives the distance, or the magnitude of the distance always represents the displacement. So it is very easy to find the area of this quadrilateral ABCD. So the area of this quadrilateral always gives the distance, or the magnitude of the distance gives the displacement of the body from A to B. Are you clear? With the graph, we can find the distance traveled by the body from A to B, or the displacement from A to B. Okay. Now, the distance traveled by the body from A to B is the area of the shaded region. This shaded region always indicates, what is that? Distance traveled by the body. Are you clear? So this is the advantage of velocity and time graph. Okay, children, I hope I made the concept crystal clear to you. Do like my video and share to your friends. Do subscribe and share and support my channel. Thank you, children. Don't miss to watch the next video. It is completely numerical problems on motion. Okay. Thank you.